Sure it's cooking. Yep, okay. All right, so for the quiz, describe the process by which merge sort sorts an array of numbers. So what does it do? It continually splits the list of numbers, the array of numbers, in half until it finally gets down to something that's guaranteed to be sorted, which is a one list. And then it sorts those sublists through a merge step, where it walks through the first list and it walks through the second list, merging them together into a single list of sorted values. Do that over and over and over again, and eventually you have an entire list of sorted values. Something along those lines. Okay, repeatedly split the data in half until it's, and then merge it until it's sorted. Something like that. All right, so let's look at where we left off in the code, because I did promise you an assignment today, right? I'm pretty sure I did.
We never started the code.
Huh?
We didn't start the code out.
Well, then we should probably start the code. Did we really not start the code?
No, we didn't.
We've just been walking through it, all the details. We've done everything but coding.
We
set up the methods.
Yeah.
All right.
We got the integers like.
Oh, when did you get here? You missed a quiz.
Yeah, I live with three 21-year-old children who like to make me late for everything. So I apologize.
Well, I didn't
I
miss.
thought it was funny to like put a
I-
freaking ranch at my door, so I walked out and like.
I didn't miss the quiz. You don't have to apologize to me. They put ranch.
At my door, so when I walked out, pants and shoes, pants and socks were ended. So then I had to change all of that, then brush my teeth. I was late.
Did you slip on the ranch?
Almost.
So how did they get on your pants?
I don't, cause I just stepped on it and just splattered everywhere.
So they put like a lot of ranch.
It's either that or change my alarm. It's one of the two that really did.
So they would change your alarm so you don't get up on time?
That or I wake up at like 2 in the morning for some reason.
Are these like friends of yours?
You can call them that. Yes.
How do you live with these people?
It doesn't sound like a friend to me.
Like I said, 3 21-year-old children.
Okay, so we started writing the code a little bit last time. So we have our main. We went ahead and gave ourselves a sample array here. The idea is we should be able to display the array, then call our merge sort, then display the array again, and it should all just work. Shut up! All right, so in any case, we wrote a little display array. We created our merge sort, which then calls our merge sort helper so that the user who is calling merge sort doesn't have to worry about the begin and end crap. So we can just call merge sort up here and it looks all pretty, no problem, blah, blah, blah. And then we have the additional details in merge sort helper. So when we make our initial call to merge sort, we're going to pass the array along, as well as the initial begin, which is 0, and the initial end, which is ar.length minus 1. So last class we decided as a group, I believe, that end was always going to be the last legal bucket in the list that we're interested in. Okay, so down in merge sort helper, we have to keep track of our begin left, end left, begin right, end right, so on and so forth. So whenever merge sort helper gets called, we know the left half of the list, and this is, we're only in this if statement if begin is not equal to end, which means what? It's not a one list, right? It's not a one list, which means it's not currently sorted. So it's not currently sorted. We're going to get begin left, so the left half of this guy, and we can look at our picture while we're doing this. So left half of this guy, so for this is the whole list we pass in, initially begin and end. Begin is 0. Oh, hello. End is the last legal bucket, which would be 9, correct? In this particular example. So we're going to create another variable called begin left, and begin left is going to be equal to the same thing as begin. That is the first part of the left half of our list. So if this is the left half of our list, the first bucket of that is 0. Okay? The last bucket of it should be, in this case, 4. So we need to get end left. Then we need to get begin right. And we need to get end right. Now we already have end right set up as being equal to end. Those are the easy ones, right?
We begin right here. We had set n left plus 1.
Right, but we don't know what end left is yet. Yeah, so we don't. So we can say end left plus 1. But we don't know what that guy is yet. So we haven't solved. So we need to. So begin left will be end.
No.
No.
I'm sorry, begin. Thank you. Begin left will be begin, same as our original. End right will be end, the same as our original. Begin right will be whatever end left plus 1 is. So the very next bucket after end left. So end left is what we need to figure out here. All right, we need to come up with the math for this. Now, we need to look at this a couple different ways. Initially, we're looking at an entire list here. Okay, so we can take the length of this list, which is 10. 10 divided by 2 is 5. Is that the middle? So you can say take that minus 1. That gets us to the middle since it's 0 based. Okay, well, does that work if we're dealing with the left half, or the right half? What's the length of that? Should be 5, right? But we can't just ask the length of that array, because we're only looking at a portion of the array. How do we get a 5 out of that?
Total length minus the first part.
Well, how do you get the total length? I'm only looking at the right half here. So I have begin as 5, and I have end as 9. Those are the numbers I'd be working with down here. End minus begin, so that's 9 minus 4, 9 minus 5, which is 4.
Divide by 2.
Why divide by 2?
You have to divide by 2 to split it in half.
Well, I just want to know what the length is. Start with just that. We should get a 5 out of this, right? The length of this right half of the list is a 5. How did we solve for that? 9 minus 5. So begin was 5, end was 9. So end minus begin plus 1. Okay, does that work in our original? 9 minus 0 plus 1 is 10. That's the length. Okay, so we could add a variable in here called length. And length is end minus begin plus 1. That's what length is. That's the number of buckets we're currently dealing with. All right, let's add that variable in. End minus begin plus 1. That's our length. We can't just say AR.length, because AR, we're always passing the same array everywhere. We're only just interested in a portion of that array set aside by begin and end. So we need to know about the length of the part of it we're interested in. All right, so now we know what length is. That's the number of characters in the portion we're interested in, number of buckets in the portion we're interested in. So now we need to figure out where end left is. In this current example, end left should be a 4. Okay? In this other example here, end left should be a 7. So we decided it would be the bigger half would be the left half. So we need to come up with an algorithm that gives us a 7 when begin is 5 and end is 9, and an algorithm that gives us a 4 when begin is 0 and end is 9. So this is coming back where he was saying you got to divide by 2. So we could take the length, which is in this case, a 5, right? If we're only looking at the right half here. Length is 5. 5 divided by 2 is what? Integer division, it's 2. Okay? So then what do we do with that 2? We definitely don't want the middle to be at 2. Do we add it to begin? So begin, if begin is 5, begin plus length divided by 2 gets us a 7 here. Begin plus 5 gets us a what? Row. We need a consistent algorithm. It's got to work every single time. So the length of this guy is 10. 10 divided by 2 is 5. Begin plus 5 is 5. That's not the right center.
You have to do 1. You have to subtract 1 because it goes from 0 to 9.
Okay, so you want to subtract 1 from it?
Yeah.
Okay, that gets us the 4 here. Now let's go to the right half. Length is 5. 5 divided by 2 is 2. Begin plus 2 is 7. Minus 1 is 6. Is that a valid left end? It is if we always treat the left half as the smaller half. Kind of changing our decision a little bit. If we have the 5 list, if this is our list, we cannot divide this evenly. So we either have a left half that's these 2, and a right half that's these 3, or a left half that's these 3, and a right half that's these 2. It doesn't matter which of those it is, as long as we always make the same decision. We can't sometimes have a left list of 3 and sometimes have a right list of 2. Math has to be consistent. So the algorithm we just came up with does give us a left half that is legitimate, correct? It is legitimate. So that is that's length divided by 2 plus begin will get us to a 6. Plus begin minus 1 will get us to the 6. Just like begin plus length divided by 2 will get us to a minus 1 will get us to a 4. So right now, our suggested end right, or end left is begin plus length divided by 2 minus 1. That's our current suggested algorithm for end left. Now let's look at it if we're dealing with the left-hand side of the list. So that's the left half. Length of this is 5. 5 divided by 2 is 2, integer division. 0 plus 2 minus 1 gets us right here. That's legit. Okay, so does this work? All right, so now we've made the decision that we're always going to take the left half as the smaller half. Because now we have a consistent algorithm that works whether we're dealing with the first part of the list, the second part of the list, or the entire list. All right, so let's make sure our variables are all set here. Here's length. Begin left is that. End left is equal to begin plus length divided by 2 minus 1. Okay, and we know this will do integer division. which is not allowed to have decimal places. Does integer division round? What does it do? Truncates, cuts it off. Okay, so 2.99 or 2.01 are both 2 with truncation. All right, so that's our end left. Begin right will be whatever that is plus 1. That's the beginning of the second half of the list. So back to our picture here. If end left is that guy, begin right will be that guy, 4 plus 1. If end left is this guy, begin right will be that guy. If end left is this guy, begin right will be that guy. Make sense? Everything's relative to begin, end. So this is one of the challenges with merge sort that you have to draw the picture for, because it's easy to fall prey to using the array's length rather than solving for the length of the portion of the array you're currently looking at. That make sense?
So to change it up, and if we wanted the left half to be the bigger half, would we change it to plus 1, and then for begin right, make it end left plus 2?
Okay, so if you wanted the left half to be the bigger part, so if we're looking at the 5 list, that's the bigger piece.
Yeah.
So you would take length. Well, you take begin plus length divided by 2, so that would be begin plus 2, which would take us here. Add 1 to it is there. Well, now end isn't. But what could we do? We could set begin right to that, and then end left to be that minus 1. Is that what you were saying?
I don't think so.
Okay, so to get the left half, what you would do is you'd solve for begin right. And then subtract 1 to get your end left. Does that make sense? So what he wanted to do is he wanted to take the length of this thing, we're looking at a 5 list, divide that by 2, which is 2, add that to begin, which takes us to 2, add 1 to that, instead of subtract 1, add 1, which takes us to 3, and that becomes the beginning of the right half, which is the smaller half now. Then we could subtract 1 from that to get us to the end of the left half. Now let's see if that holds true for the whole list. Length divided by 2 is 5. 0 plus 5 is here. Plus 1 is here. So this would be begin right in that case. This would be end left. Is that correct? It's the wrong end left. Now let me ask you this. If we have the 10 list like we have here, does splitting it in half, is splitting it exactly in half a requirement? Most optimally, we split it in half. But it's not a requirement as long as we're always splitting it the same way. So you don't abandon any buckets. You need to account for every single bucket. Okay? Right. It doesn't matter if the left half is that and the right half is that. It will still work as long as we're always splitting it identically. Okay? But I think our algorithm here seems to be consistent throughout. Seems to work, at least based on our testing up to this point. So let's make sure our variables are all set correctly. Length is equal to end minus begin plus 1. Begin left is equal to begin. End left is begin plus length divided by 2 minus 1. Begin right is that number plus 1. And end right is end. Make sense? So really, the hard part of what we just did, the hard part of merge sort, is setting those 5 variables. And we had to draw pictures just to set some numbers up to make sure the numbers were correct. Now we're going to call merge sort on the left half. Well, where's the beginning of the left half? It's begin left, where's the end of the left half? It's end left. So we'll call driver dot merge sort helper, passing it our array, passing it begin left, and passing it end left. We'll also call merge sort helper on the array, passing it begin right and passing it end right. Make sense? So we're calling this method recursively, calling itself, passing it a smaller portion of the list. And remember, we're only doing this stuff if begin is not equal to end. Because if begin is equal to end, then we're looking at one list, which is by definition sorted. All right, so after we return from our two calls to merge sort, when we eventually return from the two halves, then we need to merge those halves, because we know that the portion of AR between begin left and end left should currently be sorted. Might be the one list sorted, but it should currently be sorted. We know that the portion of the array from begin right to end right should also be sorted. Now we need to merge them together so that they're sorted in and of themselves. Make sense? All right, so if you remember the algorithm for doing that, we needed to create a temporary array. Like, didn't we even write this stuff out? Merge algorithm. Create a pointer to the beginning of each half. Already have that. Two variables. Okay, we have begin left and we have begin right. So pointers to our beginning of each half, correct? Create a temp array that is capable of holding a number of values equal to the length of the left list plus the length of the right list. We happen to already have a variable called length. That is the total length of this list. All right, so let's go create that. So we're going to create an integer array called temp, which is equal to a new integer array of length. That's the variable we solved for right up here. Okay, so one thing to keep in mind as we go through here, that sometimes when you're learning recursion, because it is a little cryptic to learn recursion, that we lose track of, we solved for all these variables first. Then we called ourselves recursively twice, which then had their own copies of these variables that were different. Once we get past these two calls to merge sort and we're down here, we still have access to all the variables that we had set up for this particular call to merge sort helper. So we know the length of this particular portion of the list. We know the begin left of this particular portion of the list. We know the end left for this particular portion of the list, so on and so forth. So when we're down here, we can use all those values to their fullest to solve this problem. All right, so we're going to create our temporary array. We're going to use that for doing the merging. Then, while at least one of the begin variables points to a legal position, okay, so while at least one of them points to a legal position, we will continue to merge. So let me ask you a question here. To fully merge the left half of our list here and the right half of our list, how many comparisons do we need to make? How many values do we need to place? Do we know exactly how many times we need to spin? I see people shaking their head no. Anybody want to shake their head yes? If I have a, look here, let me show you the picture here. If we're looking at this, and the left half of our list looks like that, and the right half looks like that, do we know how many total values we're sorting? How many? 5. Exactly 5. Will it ever be less? Will it ever be more? No, exactly 5. Do we have that 5 stored somewhere? Length. What kind of loop do we use when we know how many times we want to spin through? kind of loop lends itself to problems where we know how many times we need to do something. For loop. So for int I is equal to 0, I is less than, we can say length or temp dot length. Those are synonyms, right? Temp was built in terms of our length variable. I plus plus. So our goal here is to completely fill up temp. All right. Now, how do we test to see if our left pointer is pointing to an illegal position? What does it mean for begin left to currently not be legal as a position of the left array, the left portion of our array? So if begin left starts here, is it still legal if this is our list? We're just looking at the left half here. If begin left is this first guy, is it still legal here? Yep. Is it still legal here? Remember,
No.
left half was the smaller half and everything, right? So when it gets here, it's not legal. How do we check to see that it's not legal? How do we ask, is begin left pointing to a legal position?
Can't be greater than end left.
Can't be greater than end left. So as long as it is less than or equal to end left, because we chose end left, we chose our ends to be legal buckets, right? We decided that end would be equal to the last position in that particular part of the list. So as long as begin left is less than or equal to end left, it's a legal position, which means it's an illegal position if it's greater than end left. So if begin left is greater than end left, that means that we've already placed everything from the left half of our array. Correct? Therefore, the only possible winner is the current position we're looking at in the right half of our array. We know that we're going to loop through here the correct number of times. Correct? So if we're in here, winner is the cur position in the right half. Else if begin right is greater than end right, winner is cur position in the left half. Else. If I'm in this else, what does that mean?
Has to be equal.
What has to be equal?
Begin left and end left, or begin right and end right.
What does this if statement ask?
It's if it's begin left is less than left, it goes to the also.
Okay, so this says if begin left is illegal, then go ahead and assume the winner is the right. This if statement says if begin right is illegal, then the winner by default is the left. If we're in this else, that means that neither begin left or begin right are illegal, which means they both point to real places. That make sense? Therefore, we need to compare them, because we only want the smaller of the two. So inside here, this means both begin left and begin right point to real places, or legal places. Here, let's say legal. Legal places. So now we need to compare. So if AR at bucket begin left is smaller than AR at bucket begin right, if that's a true statement, then begin left is the winner. I'm commenting here. Else, begin right is the winner. That make sense? Now, what do we do when begin left is the winner? If we're comparing two values, whether it's the left guy to an illegal position, or the right guy to an illegal position, or the left guy to the right guy, and we decide that the left guy wins for whatever reason, what do we do? Go ahead.
Do you increment the position of the left counter?
Yes, what do we do before we do that? Already doing the comparison. So we either have a default winner here, or a default winner here, or we've done our comparison here.
Oh, you put it in the temporary?
Yeah, I got to store it. Yeah, let's store the winner and then increment who won, so we don't check that guy again. Okay, so if the winner, here we'll do it. We'll go up here. If the winner was the right half, then what we're going to do is we're going to say temp at bucket I is equal to AR at bucket begin right. Mark our winner, and then begin right plus plus. If the winner was our left half, we'll say temp at bucket I is equal to AR at position begin left. And then begin left plus plus. Make sense? So this guy says, if the right was the winner, make him the winner. If the left was the winner, make him the winner. Else, this guy says the left was the winner. What do we do when the left is the winner? We make him the winner. What do we do when the right is the winner? We make him the winner. So store it in bucket I of temp, because we know that I will go through all the buckets of temp. So we'll store the current winner in that bucket, and then increment the appropriate begin right or begin left, so that the next time through this loop we're comparing the correct positions for merging. That make sense? Remember from last time, if we were comparing, if we had the 5 list, I know these guys are already sorted, but if that's our 5 list, the beginning of the first part was here, the beginning of the second list was here. We would compare this guy to this guy, choose our winner, and increment the other guy. So let's say this guy was our winner. Next time through, we compare this guy to this guy, choose our winner. Let's say this guy was the winner. Next time through, we compare this guy to this guy, choose our winner, so on and so forth. Okay, so we need to make sure we increment begin left and begin right, so they keep walking down our list, knowing that we're going to go through the exact correct number of times, because we need to go through length number of times. We need to correctly place length number of values. Okay, so while at least one of the begin variables points to a legal position, we continue to merge. To merge, we compare the values at left begin to the value at right begin and store the smaller in our temp array. That's what we just did. Finally, we need to copy the contents of temp into the portion of the array we are currently looking at, overwriting any values in the original array. So at this point, we've gone through our original array and copied the values in the appropriate order into temp. So temp is the sorted version of our original array from begin left to, from begin to end. Okay? Now we need to take temp and copy the values back into our array, overwriting the unsorted, presumably unsorted values there, with the now sorted version of themselves that's stored in temp. So that means for AR, we need to fill AR up with all the values from buckets begin to end, including end, because we decided end was a legal position. So we're going to make bucket 0